Look at these pictures. In the first picture, here you see the liquid water is changing into gas or as vapor, and that is happening at room temperature. In the next picture again, we have the liquid water here is changing into vapor. It is okay. This again is at room temperature. Here there were some wet clothes. These clothes are drying here, so there were water molecules in this, and hence they were wet. These clothes were wet, and after some time the clothes dried up. What happened to the water? The water moved out into the air, and the liquid water which was in the clothes turned into vapor. In this next picture here, when we see water spilling on the ground, after a few hours we find the water has disappeared. What has happened to the water? The liquid water changes into vapor. In all these cases, we see that the liquid water changes into vapor. Even in boiling, liquid water changes into vapor. But what's the main difference here? Here it happens at room temperature, and this is evaporation. Changing of liquid water into vapor. So again, we just go over this again. So I have liquid water changing into vapor at room temperature, and this is evaporation. However, here when liquid water changes at vapor at boiling point is boiling. This is the difference in both, in evaporation as well as boiling. The same thing happens. Liquid changes to vapor, but in evaporation it happens at room temperature, like in all the 4 cases we have seen above. But in boiling, it happens at boiling point. We'll see at molecular level what happens in evaporation. Here we have molecules of liquid or molecules of water which are in the liquid. Now these molecules of water, here there is heats in the surrounding. These molecules which are on the surface, they will pick up the heat from the surrounding, and now when they pick up the heat from the surrounding, they can overcome these forces of attraction. And because they can overcome the forces of attraction, they are able to leave the liquid. So they pick up this heat, and those that have picked up the heat and can break free from the forces of attraction, they leave the liquid, and that is evaporation. So you always find the surface molecules first evaporating, because they being on the surface, they are able to leave the liquid more easily. So I'll just repeat it again. Here is the water molecules, they take up the heat, especially the surface molecules, they take up the heat from the surrounding, and when they take up the heat from the surrounding, they are able to free themselves from these forces of attraction, and they escape into the air. So here we have vapor. So since these water molecules absorb the heat from the surrounding and escape into the air, we can say evaporation. Evaporation, we can say, causes cooling. Look at this picture of this little boy, and he's sprinkling water on the ground, in order to cool it. And why does the sprinkling of water on the ground cool it? Now we see here that the ground, there is heat, which is denoted by these red dots, and when he sprinkles water, these water molecules, when they fall on the ground, they pick these water molecules here, they pick the heat. See, they pick the heat from the ground and then they move up. So as they vaporize and they move up, they pick up the heat from the ground, and this cools the ground. So here's another example where evaporation causes cooling. Here's yet another example to show that evaporation causes cooling. After a rigorous exercise, we sweat. So we've seen this little boy, he's sweating after a rigorous exercise. And then here, see, he goes out in the breeze, and then he finds himself feeling cool. Now, why does he feel cool? It's because this heat from his body is taken away by the sweat. The sweat evaporates, and as the sweat evaporates, as the sweat evaporates from his body, it takes away the heat of his body, and hence he feels cool. Another example is when we put scent on our body, we feel cool, because in that area where we have put scents, suppose here we put some scent here, this is the scent, we feel cool in this area, because this scent molecules, as they move out of the body, as they evaporate out, they take along with them the heat from the body, and this area then feels cool. Here this area feels cool.